I find that large language models do help with coding, right? So it's an extremely useful application that is for a lot of people taking Stack Overflow out of their life in exchange for something that is more efficient. I feel that ChatGPT is like an intern that I have to micromanage. I've have been working with people in the past who were less capable than ChatGPT. And I'm not saying this because I hate people, right? They personally, as human beings, there was something present that was not there in ChatGPT, which was why I was covering for them. But ChatGPT has an interesting ability. It does give people superpowers. And the people who feel threatened by them are the prompt completers. They are the people who do what ChatGPT is doing right now. So if you are not creative, if you don't build your own thoughts, if you don't have actual plans in the world, and your only job is to summarize emails and to expand simple intentions into emails again, then ChatGPT might look like a threat. But I believe that it is a very beneficial technology that allows us to create more interesting stuff and make the world more beautiful and fascinating if we find to build it into our life in the right ways. So I'm quite fascinated by these large language models, but I also think that they are by no means the final development. And it's interesting to see how this development progresses. One thing that the out-of-the-box vanilla language models have as a limitation is that they have still some limited coherence and ability to construct complexity. And even though they exceed human abilities to do what they can do one shot, typically when you write a text with a language model or using it, or when you write code with a language model, it's not one shot because there are going to be bugs in your program and design errors and compiler errors and so on. And your language model can help you to fix those things. But this process is out of the box not automated yet. So there is a management process that also needs to be done. And there are some interesting developments, Baby AGI and so on, that are trying to automate this management process as well. And I suspect that soon we are going to see a bunch of cognitive architectures where every module is, in some sense, a language model or something equivalent. And between the language models, we exchange suitable data structures, not English, and produce compound behavior of this whole thing.
So do some of the quote unquote prompt engineering for you.
Yeah.
They create these kind of cognitive architectures that do the prompt engineering, and you're just doing the high level meta prompt engineering.
There are limitations in a language model alone. I feel that part of my mind works similarly to a language model, which means I can yell into it a prompt and it's going to give me a creative response. But I have to do something with this response first. I have to take it as a generative artifact that may or may not be true. It's usually a confabulation. It's just an idea. And then I take this idea and modify it. I might build a new prompt that is stepping off this idea and develops it to the next level, or put it into something larger, or I might try to prove whether it's true or make an experiment. And this is what the language models right now are not doing yet. But there's also no technical reason for why they shouldn't be able to do this. So the way to make a language model coherent is probably not to use reinforcement learning until it only gives you one possible answer that is linking to its source data, but it's using this as a component in the larger system that can also be built by the language model or is enabled by language model structured components, or using different technologies. I suspect that language models will be an important stepping stone in developing different types of systems. And one thing that is really missing in the form of language models that we have today is real-time world coupling. Right? It's difficult to do perception with a language model and motor control with a language model. Instead, you would need to have different type of thing that is working with it. Also, the language model is a little bit obscuring what its actual functionality is. Some people associate the structure of the neural network of the language model with the nervous system, and I think that's the wrong intuition. The neural networks are unlike nervous system. They are more like 100-step functions that use differentiable linear algebra to approximate the correlation between adjacent brain states. It's basically a function that moves the system from one representational state to the next representational state. Right? So it's if you try to map this into a metaphor that is closer to our brain, imagine that you would take a language model or a model like DALL-E that you use, for instance, with image-guided diffusion to approximate a camera image and use the activation state of the neural network to interpret the camera image, which in principle I think will be possible very soon. You do this periodically. And now you look at these patterns, how when this thing interacts with the world periodically look like as in time. And these time slices, they are somewhat equivalent to the activation state of the brain at a given moment.
How's the actual brain different? Just the asynchronous craziness?
For me, it's fascinating that they are so vastly different and yet in some circumstances produce somewhat similar behavior.
Right.
And the brain is, first of all, different because it's a self-organizing system where the individual cell is an agent that is communicating with the other agents around it and is always trying to find some solution. And all the structure that pops up is emergent structure. So one way in which you could try to look at this is that individual neurons probably need to get a reward, so they become trainable, which means they have to have inputs that are not affecting the metabolism of the cell directly, but they are messages, semantic messages that tell the cell whether it has done good or bad and in which direction it should shift its behavior. Right? Once you have such an input, neurons become trainable, and you can train them to perform computations by exchanging messages with other neurons. And parts of the signals that they are exchanging and parts of the computation that are performing are control messages that perform management tasks for other neurons and other cells. I also suspect that the brain does not stop at the boundary of neurons to other cells, but there are many adjacent cells will be involved intimately in the functionality of the brain and will be instrumental in distributing rewards and in managing its functionality.
It's fascinating to think about what those characteristics of the brain enable you to do that language models cannot do.
So first of all, there's a different loss function at work when we learn.
Yeah.
And to me, it's fascinating that you can build a system that looks at 800 million pictures and captions and correlates them, because I don't think that a human nervous system could do this. For us, the world is only learnable because the adjacent frames are related. And we can afford to discard most of that information during learning. We basically take only in stuff that makes us more coherent, not less coherent. And our neural networks are willing to look at data that is not making the neural network coherent at first, but only in the long run. By doing lots and lots of statistics, eventually patterns become visible and emerge. And our mind seems to be focused on finding the patterns as early as possible.
Yeah, so filtering early on, not later.
Yes, it's a slightly different paradigm, and it leads to much faster convergence. So we only need to look at a tiny fraction of the data to become coherent. And of course, we do not have the same richness as our trained models. We will not incorporate the entirety of text in the internet and be able to refer to it and have all this knowledge available and being able to confabulate over it. Instead, we have a much, much smaller part of it that is more deliberately built. And to me, it would be fascinating to think about how to build such systems. It's not obvious that they would necessarily be more efficient than us on a digital substrate, but I suspect that they might. So I suspect that the actual AGI that is going to be more interesting is going to use slightly different algorithmic paradigms, or sometimes massively different algorithmic paradigms than the current generation of transformer-based learning systems.
Do you think it might be using just a bunch of language models like this? Do you think the current transformer-based large language models will take us to AGI?
My main issue is I think that they're quite ugly and brutalist.
Which brutalist?
Yes.
Is that what you said?
Yes, they are basically brute forcing the problem of thought. And by training this thing with looking at instances where people have thought and then trying to deepfake that. And if you have enough data, the deepfake becomes indistinguishable from the actual phenomenon. And in many circumstances, it's going to be identical.
Can you deepfake it till you make it? So can you achieve, what are the limitations of this? I mean, can you reason? Let's use words that are loaded.
Yes, that's a very interesting question. I think that these models are clearly making some inference.
Yeah.
But if you give them a reasoning task, it's often difficult for the experimenters to figure out whether the reasoning is the result of the emulation of a reasoning strategy that they saw in human written text, or whether it's something that the system was able to infer by itself. On the other hand, if you think of human reasoning, if you want to become a very good reasoner, you don't do this by just figuring out yourself. You read about reasoning. And the first people who tried to write about reasoning and reflect on it didn't get it right. Like even Aristotle, who thought about this very hard and came up with a theory of how syllogisms works and syllogistic reasoning, has mistakes in his attempt to build something like a formal logic and gets maybe 80% right. And the people that are talking about reasoning professionally today read Tarski and Frege and build on their work. So in many ways, people, when they perform reasoning, are emulating what other people wrote about reasoning, right? So that it's difficult to really draw this boundary. And when François Chollet says that these models are only interpolating between what they saw and what other people are doing, well, if you give them all the latent dimensions of that can be extracted from the internet, what's missing? Maybe there is almost everything there. And if you're not sufficiently informed by these dimensions and you need more, I think it's not difficult to increase the temperature in the large language model to the point that is producing stuff that is maybe 90% nonsense and 10% viable, and combine this with some prover that is trying to filter out the viable parts from the nonsense in the same way as our own thinking works, right? When we're very creative, we increase the temperature in our own mind and we create hypothetical universes and solutions, most of which will not work. And then we test. And we test by building a core that is internally coherent. And we use reasoning strategies that use some axiomatic consistency by which we can identify those strategies and thoughts and sub-universes that are viable and that can expand our thinking. So if you look at the language models, they have clear limitations right now. One of them is they're not coupled to the world in real time in the way in which our nervous systems are. So it's difficult for them to observe themselves in the universe and to observe what kind of universe they're in. Second, they don't do real-time learnings. They basically get only trained with algorithms that rely on the data being available in batches. So it can be parallelized and runs efficiently on the network and so on. And real-time learning would be very slow so far and inefficient. That's clearly something that our nervous systems can do to some degree. And there is a problem with these models being coherent. And I suspect that all these problems are solvable without a technological revolution. We don't need fundamentally new algorithms to change that. For instance, you can enlarge the context window and thereby basically create working memory in which you train everything that happens during the day. And if that is not sufficient, you add a database and you write some clever mechanisms that the system learns to use to swap out in and out stuff from its prompt context, right? And if that is not sufficient, if your database is full in the evening, overnight you just train. If the system is going to sleep and dream and is going to train the stuff from its database into the larger model by fine-tuning it, building additional layers and so on. And then the next day it starts with a fresh database in the morning with fresh eyes, has integrated all this stuff. And, you know, when you talk to people and you have strong disagreements about something, which means that in their mind they have a faulty belief or you have a faulty belief with a lot of dependencies on it, very often you will not achieve agreement in one session, but you need to sleep about this once or multiple times before you have integrated all these necessary changes in your mind. So maybe it's already somewhat similar.
Yeah,
right?
There's already a latency even for humans to update the model, to retrain the model.
And of course, we can combine the language model with models that get coupled to reality in real time. And we can build multimodal model and bridge between vision models and language models and so on. So there is no reason to believe that the language models will necessarily run into some problem that will prevent them from becoming generally intelligent. But I don't know that. It's just, I don't see proof that they wouldn't. My issue is I don't like them. I think that they're inefficient. I think that they use way too much compute. I think that given the amazing hardware that we have, we could build something that is much more beautiful than our own mind. And this thing is not as beautiful as our own mind, despite being so much larger.
But it's a kind of proof of concept.
It's the only thing that works right now, right? So it's not the only game in town, but it's the only thing that has this utility with so much simplicity. There's a bunch of relatively simple algorithms that you can understand in relatively few weeks that can be scaled up massively.
So it's the deep blue of chess playing. Yeah, it's ugly.
Yeah, Claude Shannon had this, when he described chess, suggested that there are two main strategies in which you could play chess. One is that you are making a very complicated plan that reaches far into the future, and you try not to make a mistake while enacting it.
Mm-hmm.
And this is basically the human strategy. And the other strategy is that you are brute forcing your way to success, which means you make a tree of possible moves where you look at, in principle, every move that is open to you, all the possible answers, and you try to make this as deeply as possible. Of course, you optimize, you cut off trees that don't look very promising, and you use libraries of end game and early game and so on to optimize this entire process. But this brute force strategy is how most of the chess programs were built. And this is how computers get better than humans at playing chess. And I look at the large language models, I feel that I'm observing the same thing. It's basically the brute force strategy to thought by training the thing on pretty much the entire internet. And then in the limit, it gets coherent to a degree that approaches human coherence.
Yeah.
And on a side effect, it's able to do things that no human could do, right? It's able to sift through massive amounts of text relatively quickly and summarize them quickly, and it's never lapses in attention. And I still have the illusion that when I play with ChatGPT, that it's in principle not doing anything that I could not do if I had Google at my disposal and I get all the resources from the internet and spend enough time on it.
Mm-hmm.
But this thing that I have an extremely autistic, stupid intern in a way that is extremely good at drudgery, and I can offload the drudgery to the degree that I'm able to automate the management of the intern is something that is difficult for me to overhype at this point, because we have not yet started to scratch the surface of what's possible with this.
But it feels like it's a tireless intern, or maybe it's an army of interns. And so you get to command these slightly incompetent creatures. And there's an aspect, because of how rapidly you can iterate with it, it's also part of the brainstorming, part of the kind of inspiration for your own thinking. So you get to interact with the thing. I mean, when I'm programming or doing any kind of generation with GPT, it somehow is a catalyst for your own thinking in a way that I think an intern might not be.
Yeah, where it gets really interesting, I find, is when you turn it into a multi-agent system. So, for instance, you can get the system to generate a dialogue between a patient and a doctor very easily. But what's more interesting is you have one instance of ChatGPT that is the patient, and you tell it in the prompt what kind of complicated syndrome it has. And the other one is a therapist who doesn't know anything about this patient, and you just have these two instances battling it out and observe the psychiatrist or a psychologist trying to analyze the patient and trying to figure out what's wrong with the patient. And if you try to take a very large problem, the problem, for instance, how to build a company, and you turn this into lots and lots of sub-problems, then often you can get to a level where the language model is able to solve this. What I also found interesting is, based on the observation that ChatGPT is pretty good at translating between programming languages, but sometimes has difficulty to write very long coherent algorithms that you need to co-write them with human author. Why not design a language that is suitable for this? So some kind of pseudocode that is more relaxed than Python, and that allows you to sometimes specify a problem vaguely in human terms and let ChatGPT take care of the rest. And you can use ChatGPT to develop that syntax for it and develop new kinds of programming paradigms in this way. So we very soon get to the point where this question, the age-old question for us computer scientists, what is the best programming language, and can we write a better programming language now? That is, I think that almost every serious computer scientist goes through a phase like this in their life. This is a question that is almost no longer relevant, because what is different between the programming languages is not what they let the computer do, but what they let you think about what the computer should be doing. And now the ChatGPT becomes an interface to this, in which you can specify in many, many ways what the computer should be doing, and ChatGPT or some other language model or combination of system is going to take care of the rest.
And allow you expand the realm of thought you're allowed to have when interacting with the computer.
Mhm.
It sounds to me like you're saying there's basically no limitations. Your intuition says to what large language
I don't
models
know
can
of that limitation. So when I currently play with it, it's quite limited. I wish that it was way better.
But isn't that your fault versus the large
I don't
language
know.
model?
Of course, it's always my fault. There's probably a way to
Is
make it work
everything your
better.
fault? I just want to get you on the record as saying
Yes, everything is my fault. That doesn't work in my life. At
Yeah.
least that is usually the most useful perspective for myself. Even though with hindsight, I feel no. I sometimes wish I could have seen myself as part of my environment more and understand that a lot of people are actually seeing me and looking at me and are trying to make my life work in the same way as I try to help others.
Mhm.
And making this switch to this level 3 perspective is something that happened long after my level 4 perspective in my life. And I wish that I could have had it earlier. And it's also not now that I don't feel like I'm complete. I'm all over the place. That's all.
Where's happiness in terms of stages? Is it on 3 or 4 if
No,
you take that tangent?
you can be happy at any stage or unhappy.
Oh.
But I think that if you are at a stage where you get agency over how your feelings are generated, and to some degree you start doing this when you leave adolescence, I believe, that you understand that you're in charge of your own emotion to some degree, and that you are responsible how you approach the world. That it's basically your task to have some basic hygiene, how in the way in which you deal with your mind, and you cannot blame your environment for the way in which you feel. But you live in a world that is highly mobile, and it's your job to choose the environment that you thrive in and to build it. And sometimes it's difficult to get the necessary strength and energy to do this and independence. And the worse you feel, the harder it is. But it's something that we learn. It's also this thing that we are usually incomplete. Right? I'm a rare mind, which means I'm a mind that is incomplete in ways that are harder to complete. So for me, it might have been harder to initially to find the right relationships and friends that complete me to the degree that I become an almost functional human being.
Oh man, the search space of humans that complete you is an interesting one, especially for Joscha Bach. That's an interesting, because talking about brute force search in chess.
Yeah,
I wonder what that search tree looks like.
I think that my rational thinking is not good enough to solve that task. A lot of problems in my life that I can conceptualize as software problems, and the failure modes are bugs, and I can debug them and write software that take care of the missing functionality. But there is stuff that I don't understand well enough to use my analytical reasoning to solve the issue. And then I have to develop my intuitions, and often I have to do this with people who are wiser than me. And that's something that's hard for me because I'm not born with the instinct to submit to other people's wisdom.
Yeah. So what kind of problems are we talking about? This is stage 3, like love?
I found love was never hard.
What is
Love
hard
is
then?
fitting into a world where most people work differently than you and have different intuitions of what should be done.
So empathy.
It's also aesthetics. When you come into a world where almost everything is ugly and you come out of a world where everything is beautiful. I grew up in a beautiful place and as a child of an artist.
Yeah.
And in this place, it was mostly nature. Everything had intrinsic beauty. And everything was built out of an intrinsic need for it to work for itself. Everything that my father created was something that he made to get the world to work for himself. And I felt the same thing. And when I come out into the world and I am asked to submit to lots and lots of rules, I'm asking, okay, when I observe your stupid rules, what is the benefit? And I see the life that is being offered as a reward. It's not attractive.
When you were born and raised an extraterrestrial prince in a world full of people wearing suits, so it's a challenging integration.
Yes. But it also means that I'm often blind for the ways in which everybody is creating their own bubble of wholesomeness, or almost everybody, and people are trying to do it. And for me to discover this, it was necessary that I found people who had a similar shape of soul as myself. So basically where I felt, these are my people that treat each other in such a way as if they're around with each other for eternity.
How long does it take you to detect the geometry, the shape of the soul of another human, to notice that they might be one of your kind?
Sometimes it's instantly and I'm wrong, and sometimes it takes a long time.
You believe in love at first sight, Joscha Bach?
Yes, but I also noticed that I have been wrong. So sometimes I look at a person and I'm just enamored by everything about them. And sometimes persists and sometimes it doesn't. And I have the illusion that I'm much better at recognizing who people are as I grow older.
But that could be just cynicism? No,
it's not cynicism. It's often more that I'm able to recognize what somebody needs when we interact and how we can meaningfully interact.
so
It's not cynical at all.
You're better at noticing.
Yes. I'm much better, I think, in some circumstances at understanding how to interact with other people than I did when I was young.
So that takes us
doesn't mean that I'm always very good at it.
So that takes us back to prompt engineering, of noticing how to be a better prompt engineer of an LLM. A sense I have is that there's a bottomless well of skill to become a great prompt engineer. It feels like it is all my fault whenever I fail to use ChatGPT correctly, that I didn't find the right words.
Most of the stuff that I'm doing in my life doesn't need ChatGPT. There are a few tasks that are where it helps, but the main stuff that I need to do, like developing my own thoughts and aesthetics and relationship to people, and it's necessary for me to write for myself, because writing is not so much about producing an artifact that other people can use, but it's a way to structure your own thoughts and develop yourself. And so I think this idea that kids are writing their own essays with ChatGPT in the future is going to have this drawback that they miss out on the ability to structure their own minds via writing. And I hope that the schools that our kids are in will retain the wisdom of understanding what parts should be automated and which ones shouldn't.
But at the same time, it feels like there's power in disagreeing with the thing that ChatGPT produces. So I use it like that for programming. Mm-hmm. I'll see the thing it recommends, and then I'll write different code. Yeah. I disagree. And in the disagreement, your mind grows stronger.
I'm recently wrote a tool that is using the camera on my MacBook and Swift to read pixels out of it and manipulate them and so on. And I don't know Swift. So it was super helpful to have this thing that is writing stuff for me. And also interesting that mostly it didn't work at first. I felt like I was talking to a human being who was trying to hack this on my computer without understanding my configuration very much and also making a lot of mistakes. And sometimes it's a little bit incoherent. So you have to ultimately understand what it's doing. There's still no other way around it. But I do feel it's much more powerful and faster than using Stack Overflow.